In this short presentation, we will provide some, we hope, useful insights on different educational approaches which may be employed for guiding the integration of systems thinking within the field of green chemistry. There are several pieces of evidence which show that teaching green chemistry promotes the field of chemistry as a discipline which works for the improvement of society. In short, one may state that the goal of green chemistry is to maximize the benefits of chemistry for society while minimizing its harms, and this can be advanced via a systems thinking approach. Systems thinking may be conceptualized as an approach which provides a way of avoiding complications that can arise when traditional thinking is applied to complex problems. And in addition, recognizes that complex problems arise within a system of interrelated components connected by feedback loops that generate patterns of behavior over time. In fact, as stated in the relevant literature, investigating the relationship between the structure of a system and its behavior reveals leverage points from where one can fundamentally shift the function or orientation of the entire system. Teaching chemistry through a systems approach challenges students to apply scientific principles to solve real-world problems, demonstrates chemistry's role as an essential science in finding solutions to global challenges, and prepares future scientists for the collaborative interdisciplinary work required. A framework for analysis of systems thinking in chemistry education has been developed, and its basic structure may be viewed in this figure. The chemistry learner is placed at the center of this framework, which consists of three nodes or central elements that contribute to the understanding of the interdependent components within and among the complex and dynamic systems involved in student learning. The learner systems node explores and describes the processes at work for learners, which include taxonomies of learning domains, learning theories, learning progressions, models for the phases of memory, the transition from rote to meaningful learning, and social contexts for learning. The chemistry teaching and learning node focuses on features of learning processes applied to the unique challenges of learning chemistry. These challenges include the use of pedagogical content knowledge, analysis of how the intended curriculum is implemented, assessed, learned, and applied, and student learning outcomes that involve responsibility for the safe and sustainable use of chemicals, chemical reactions, and technologies. Lastly, the Earth and Societal Systems node orients chemistry education toward meeting societal and environmental needs, articulated in initiatives such as the United Nations Sustainable Development Goals, often referred to as SDGs, and descriptions of the Earth's planetary boundaries. Educational systems that address the interface of chemistry with Earth and societal systems include green chemistry and sustainability education, and use tools such as life cycle analysis. Concentrating on the chemistry teaching and learning node, we turn our attention to green chemistry education. Green chemistry education is based on a set of 12 green chemistry principles originally proposed in the late 90s by the pioneering work of Paul Anastas and John Warner. These principles provide the basis for the design of different educational approaches via which a multitude of student skills will be subsequently developed. Review of the recent research literature points out that the most often used educational approaches that can guide the integration of systems thinking and green chemistry into the chemistry curriculum are A. Research and project-based investigations, B. Guided inquiry approaches, C. Problem-based learning. Starting with the project-based approaches, they can be used in order to promote scientific learning, cognitive and critical thinking skills, problem-solving abilities. These approaches have been proposed as critical for teaching green chemistry through a systems thinking approach and essential in bridging the gap between fundamental concepts, sustainability, and the interconnectedness with local and global systems. Moving on to the guided inquiry approaches, we note that they intend to enhance students' critical thinking, creativity, self-regulated learning, and the sense of how real-world research is done. Finally, in problem-based learning, systems thinking assists students to address complex, interdisciplinary real-world problems, to moving away from an isolated and reductionist understanding of subject matter, and to taking a more integrated and holistic analysis of problems, resulting to a more lateral understanding of entire systems by appreciating relevant links and predicting system outputs. Within the framework of green chemistry education, course-level approaches for embedding systems thinking into teaching include specific educational resources, such as laboratory experiments, technology-enhanced learning environments, game-based learning strategies. One relevant example for each resource type is given in this list of publications which appeared recently in the literature. In addition, systems thinking can be adopted as either a methodology to develop and disseminate a new green chemistry curriculum, as proposed in the work of James Hutchison, or as an integrated community-based learning project for chemistry students that allows them to see their place in complex systems as chemists and recognize their ability to make positive impacts within these global systems, as proposed in the work of Grace Lasker. Finally, several works have provided firm evidence that by incorporating systems thinking approaches within green chemistry education, this results to progress in addressing the United Nations Sustainable Development Goals shown here. Summarizing, we may conclude that the application of a systems thinking approach in green chemistry education and chemistry education more broadly can equip future generations with the skills to meet the Sustainable Development Goals, bringing the planet closer towards a sustainable society. Thank you.